All right, guys, let's do this then. So the way this meeting is going to progress is there's some unanswered questions left on the group. So first of all, I'm going to answer them, and then later on, what we're going to do is we're going to start from chapter 2 today. So chapter 2, which is motion in one dimension, like accelerated motion in one dimension. First, we're going to discuss those questions, end of chapter questions, and then we'll move on to vectors, which is just 4 questions, and then probably some of the parabolic motion, which is, I guess you guys have a bit of problem in that chapter, and that's where the real physics starts. All right, and then tomorrow we're going to do chapter 5, which is that pulley and friction, uh, plank, etc., inclined plank, inclined plane, and then the centripetal. And then last 2 days, what we're going to do is we're going to have some past paper sessions, and probably if you guys have more problems, we can book a room in the library and we can have a group practice session. All right, so let me just share my screen. Okay, so you guys can see the screen now. All right, guys, feel free to open your mic and tell me if you guys have some issues. All right, so first of all, there was this question from Zishan. It's a bit tricky. We're gonna study this tomorrow or day after tomorrow, but it's centripetal motion. So but as the person has shared it, so let's do it. The figure below shows 2 wires tied to a 6 kg mass that revolves in a horizontal circle at a constant speed of 8 meters per second. Calculate the magnitude of the tension in the upper wire. I guess this question is in the worksheet as well. Okay, so here's the worksheet. Yeah, here's the question. Come on. Calculate the magnitude of the tension in the upper wire. All right, so like there's this is tension 1 in the first wire and this is tension 2. So what I like to do in these types of questions and also parabolic motion, I like to think of it as horizontal and vertical. And here too, we're going to form 2 equations, one for the horizontal forces and one for the vertical forces, and then we'll simultaneously equate them to find the answer. All right, so it's a 6 kg mass. So 60 Newton downwards. And as this is tension 1, all right, at a constant speed of 8 meters per second. So we're going to find the centripetal force as well. All right, so what we're going to do here is as is tension 1, and let's think of this as it's like this. And this, there is an angle over here, and these angles are going to be same because these lengths are 0.6 and 1 each. So they're the same. Okay. So what we're going to do is to first of all, we're going to like break these down into horizontal and vertical, like sine and cos. Up there's going to be sine and here it's going to be cos. All right, so this is t1 sine theta, right? And here it's going to be t2 sine theta as well. And so this is going to be t1 cos, messed up a bit. All right, you guys get it, like it's cos theta, and this is t2 cos theta. All right, so what's the two equations going to be for horizontal? It's going to be, and vertical. Horizontal, it's going to be, so the centripetal force is also going inwards to the pole. So it's going to be Fc equals T1 cos theta plus T2 cos theta. And the vertical is going to be, so there is only one force going upwards, and it's T1 sine theta. So it's going to be T1 sine theta equals, and then there's 60 Newton, the weight going down, and also the vertical component of the T2. So it's going to be 60 plus T2 sine theta. All right. So what we don't know the angle here. All right, so we can't find like the theta. But what we can do is that we know that cos is what's cos? It's the adjacent over the hypotenuse. All right, and we know the hypotenuse is 1. We got to find the adjacent. We'll find it via the h square equals p square plus b square. All right, so what's gonna be the, all right, what, you know what, we don't need to do all this bullshit. Actually we need to find the a. All right, so 1 square equals 0.6 square plus b square. Can anybody help me with this? All right, I'll do it myself. 1 square minus 0.6 square and then under root this. It's gonna be 0.8. All right, so it's cos, so this adjacent is 0.8. All right, so cos theta is gonna be 0.8 over 1, right? All right, so what we're gonna do is, and what's this centripetal force? So I guess centripetal force formula is mv square over r. All right, so mass is 6 times v square. It's what's in the speed? It's 8, right? Times 8 square, and what's the this radius? It's 0.8, right? We just calculated it, 0.8, and the answer is going to come like 480 newtons. Okay, so we're going to end up with 480 equals 0.8 T1 plus 0.8 T2. I guess nobody has any problems with this, right? So this is the first equation, and for the vertical, likewise, sine is perpendicular over hypotenuse. So it's 0.6 over 1. So it's 0.6 T1 equals 60 plus 0.6 T2. All right. And this is equation number 2. We're going to simultaneously solve these. Dividing this all by 0.6 is going to be T1 equals 600, I guess. Yep, 600. 60 divided by 0.6 is 600. It's 100. It's 100. 100 plus T2. All right. So T1 equals 100 plus T2, and we'll put it over here. 480 equals 0.8 times 100 plus T2 plus 0.8 T2. And yeah, so we're going to solve this, and what we'll end up with is T2 is going to be whatever, and T1 is going to be 350, and this is what we need to find, like the tension in the upper wire, which is going to be 350. So we don't need to solve it anymore. If you guys get this answer, then that's good. Can I get like a thumbs up or something? I can't see the chat right now because I'm screen sharing. So I guess, is there anybody having any problems with this? You guys can take a screenshot of this. Okay, let me see. Nobody has any questions. Nobody's giving me any response, man. I'm like, it's like I'm talking to the wall. All right. Zishan is like, thanks, Moise. Yasin is saying, yeah, good. How
Can
would
you open your screen up again?
yeah, sure, bro. I'm just looking at the
Yeah, I'm gonna just take a screenshot.
yeah, sure, I would. How would we know from the question that the tension in both wires is different? Well, it's obvious that like if a 6 kg mass is suspended in the air and like the weight is going downwards, it's obvious that like the upper wire is gonna take more load than the lower wire, right? And if there's a pulley and there is not like a hinge between them, it's like a frictionless pulley, then the tension is gonna be same in the both in the wires. But here it's like um how would I say, there's two different wires joining with the ball. It's not like a pulley in between. So yeah, I hope that makes sense. All right. Uh, I'm going to show you again. Where was it? Oh, it's gone now. Undo, I guess. Undo. No, bro, it's gone forever. But what I can do is I can share you a picture, all right? I'll do that at the end of the class. But the main thing is you got it right. All right, so what was the next question that you guys had? So this was a question from Zishan. And yeah, here, Reese has this question, and then this no-name guy has a question. All right, let's do it. This one first. A 9 kg block is placed on a frictionless plane inclined at an angle of 30 degree to the horizontal. A horizontal force is then applied to the block to keep it stationary. Find the magnitude of this applied force. All right. So this is a question from chapter 5, but let's do it. Okay, so it's like this, 30 degree, and this has no friction, and this is 9 kg. Okay, so 90 Newton is going downwards, and then we've got this. They're saying we need to keep it stationary. So via a horizontal force, not along the plane, it's a horizontal force, all right? So, and we know that the component of weight going downwards is 90 sine 30, right? We know this formula, this is 90 sine 30, and then this is the normal force which acts is 90 cos 30, right? You guys should know this. And if you guys didn't, then I told you just right now. All right, so as we know, in math, we all know this, like if these two are parallel, then these angles are same, right? So if it's 30 degree here, then it's 30 degree here as well, okay? And this is like making a right angle triangle. So what we're gonna do is we actually need this force to be able to like the component of this horizontal force, like this component, the component parallel to the incline needs to be 90 sine 30, right? So so it's making a triangle, okay? So what we're gonna do is here it's cos 30 equals, so it's 90 sine 30, right? And then this force, horizontal force H, which we need to find over H. So H equals 90 sine 30 over 90 cos 30. So it's gonna be 90 tan 30, right? So what's 90 tan 30? It's gonna be 90 tan 30, 51, 51.9, so 52. We can round this off to 50 and then C is the answer. Okay, make sure to take a screenshot now. All right, I'm waiting. Done? Are you guys done? I'm gonna clear it. All right, bro. Okay, so we're done with this as well. And so we have this last question by Reese left. So this is kind of an easy question. It's from chapter 2. We can also find this in the worksheet of chapter 2. It's here. Like chapter 2, where is it? Why do I have a like line going? Okay, it's gone now. All right. So this question number 12. The graph below shows the velocity of a particle, velocity x of a particle moving along the x-axis. Okay, so we've got the formula. No, we've got the horizontal velocity graph here with respect to time. If x equals 2 at time t1. Okay, so at time t1, x equals 2 meters. Okay, what is the position of the particle at time equals 6? Okay, so we need to find the position of the graph of the object when the time reaches 6. And at time 1, the object is at 2 meters. And this is a velocity time graph. So we know that the area of a velocity time graph is the distance it's moved, because like v times t is d, distance equals speed times time. Okay, so what we're going to do is we're going to take this area and then this area. these two areas of triangles and we're going to add them to 2. Okay, so we've got the initial position, which is 2, and we're going to plus, what is this, half this first triangle, this one, half times, what's the base? 2 minus 1, which is 1, and then the height 2 minus 0, it's 2. Okay, so this plus, and then this is in the negative. We can deliberately minus it, or we can take these minus into consideration. Okay, so I'm going to take this minus into consideration. I'm just going to plus it. Half into what's the base going to be? It's going to be 6 minus 2, which is 4, times the height minus 2 minus 0, it's minus 2. So we're going to solve this, and it's going to end up 1 2 plus 1 3, and then 3 minus 4 is going to be minus 1. So answer is D. Come on, any questions? Take a screenshot if you guys want to. Okay, so let's move on then. Why can't I see the chat while showing the screen? This is weird. This is really weird. Okay, so to see the chat, I need to stop sharing. I did not take a screenshot. Bro, you can, like, after the class, just message me. I will share you the picture, okay? Mert says, dude, I don't understand before question, why did we equalize cos 30 and sine 30? So, which question? Which one? This one? This one? Like 30 degrees? Well, when did we equalize 30, cos 30 and like, yeah, so I told you that it's the component of weight going down the graph, down the plane is going to be weight times sine 30, right? You know that, right? So we have to find that component. Like the weight is 90, 9 kg block, so weight is 90. In physics 105, what we do is we take the free fall value as 10 opposed to 9.81 to make the calculations easier. So we take it 10, so 90 sine 30. So and that's the force going down the incline, and we need to oppose it. But the force which we are acting is horizontal, right? So what ends up happening is we make a right angle triangle over here. Let me show this again. Okay, why did we add 2 in the beginning? Because they have written in the question that at time t equals 1, the distance is 2. Let me show you guys again. Like they've written over here. Yeah. If x equals 2 at time, let me just, if x equals 2 at time t equals 1. Okay, so they've told us that at time t equals 1, the position is 2 meters, and we need to find the change in position after that, after 1 second. Okay, so it's not like at time 1 it's at 0. There is a value, they've given us the value, so it's 2, and then we're going to add upon it. Does it move forward? Like here it moves forward, and here it moves backward, because here the velocity is in negative. And it's just simple that velocity time graph, you just need to remember this small fact, that the area of a velocity time graph is the displacement, because v times t is the distance. So it's just simple. We just take this area and we take this area, and this area is going to be negative because the speed is negative. So it's automatically going to get the distance is going to get minus from the distance that we have at time 2. So it's just simple. And for the previous one, and for the previous question that Mert was asking, okay, so in 10 minutes, this meeting is going to end. So you guys need to join this meeting again. The same link will be followed. Okay, so I'm holding you guys back, but I need everybody to understand this. That this is 90 Newton, tamam, and we have this force acting. Okay, we need to act a force that's going to oppose this force, because this force is gonna get the object to slide down. But they're saying we need to keep the uh, object static. So when is an object static? When the horizontal and the forward and the backward forces are equal. Okay, so what's the backward force? It's 90 sine 30, because we've got this angle over here 30. It's just a simple fact, you can Google it. So that this is 90 sine 30 and this is 90 cos 30. This is a simple fact, but we're not gonna get into the cos part. We just have to deal with the sine part. And we know that this Z formation, so this angle is also 30. And we know that this is like a right triangle. I messed it up a bit, but it's like a right triangle. So we know that cos 30 equals the adjacent, the base, which is this 90 sine 30, and then this hypotenuse, which is a h. And then we just calculate it. We take this over there and this over here, and voila, we get the answer 50. So this is how we do it. Okay, so you guys got any question with this? Okay, tamam. Okay, so it's going good. What else? What else question did you guys have? Like these two questions are solved. This question is solved. And the previous questions I sent the answers to them, or somebody else answered them. So do you guys have any extra questions? Zoom meeting stopped? Nope. No, it's not stopped, guys. Which chapters you guys explaining? Oh, just come to the class and you'll understand. If you're in the class, I'm wanting to tell you that first we're discussing the questions that you guys have, and then we'll discuss chapter number 2, 3, and 4. Chapter 3 is just vectors, it's simple shit. So we're not gonna go into that, just chapter 2 and chapter 4. Okay, so if you guys don't have any further questions, let's just start from chapter, which chapter was it? Chapter 2. Where's chapter 2? Where's chapter 2? I guess I've opened it here. Yeah, here it is. It's really simple, chapter 2. But I need a volunteer to tell me that which question should I solve here. Can we solve some complicated questions similar to exam type? Yeah, we could actually do that, but I guess there's some people over here who don't know the simple concepts as well. So this meeting is especially beneficial for them, because if you don't know the basics, how are you going to solve the more complicated questions? You get me? So I'm just aiming to increase the average this time, so that will be a win for me. So let's just, so what I'm going to do is chapter 2, chapter 3, 4 today, and then chapter 5, 6 tomorrow, and then the last 2 days we're going to do some past paper questions. And if you've got any complicated questions, you could have sent it to me. We could have solved them now. You didn't send it to the group. We can do them tomorrow. Tamam. So what we're going to do here now is chapter 2. Actually, yeah. So what's this first question? The graph below shows how the position of a particle moving along the x-axis changes with time. Okay, and what is the average velocity of the particle between 5 and 9 seconds? Okay, 5 and 9 seconds. So they're asking us the average velocity. Okay, so how do we find this? Average velocity is average speed equals change in distance over change in time. Okay, so what's the change in distance? It goes from 12 to 0. So final minus initial 0 minus 12, and then change in time 9 minus 5 4. So it's minus 12 over 4, which is minus 3. So we've got this answer, simple. Okay, on to the next one. Over a short interval, the position of a car moves along the x-axis given by x equals this, where x is in meters and time is in seconds. The magnitudes of the velocity and acceleration of the car at t equals 1 are respectively. Okay, so they've given us the equation of the distance moved in the x-axis, where x is in meters and time is in seconds, and they're asking us the magnitude of velocity and acceleration at time 1. So what, first of all, we're going to differentiate this, because if we differentiate it, we get the equation of velocity, and then after we differentiate it again, we get the equation of acceleration, right? So for the velocity equation, v equals 15 minus 3t square, okay? And then if we put 1 here, 15 times minus 3 is going to be 12. So v is 12 meters per second at time 1. And what's going to be the acceleration? Acceleration is going to be 0 minus 6t. So if you put 1, it's going to be minus 6. So 12 and minus 6. 12 and, okay, we don't have an option for negative. So it's going to be 12 and 6. Okay, and I guess they've made a mistake here. So, okay, question number 3. A plot of an object's velocity v as a function of time. A plot of an object's velocity as a function of time is a straight line with a positive slope. Object's velocity as a function of time is a straight line with a positive slope. Okay, it's going to be something like this. Here is velocity and here is time, and crosses the x and crosses the t-axis at some time. Okay, so it's going to be from the negative. Which of the following statements is not true? So the object changes its direction of motion at some instant. Yeah, it might as well, because they've written it crosses the t-axis at some time. So here below the t-axis, velocity is negative, and above the v-axis, velocity is positive. So it's gonna go in the positive direction at some time. So this is true. B, the average acceleration of the object between any two time points is equal to its instantaneous acceleration. The average acceleration of the object between any two time points is equal to its instantaneous acceleration. Yeah. So as the graph is a straight line, we know that its gradient is going to be a straight line as well, like a straight line with zero gradient, right? We know this as a fact, and we know this that the gradient of velocity time graph is acceleration. So either if we take like these 2 points and we take the average, or we take like at a single point the instantaneous acceleration, it's both, all of them are going to be the same. Okay, so this one is true as well. The acceleration of the object is constant. We just discussed that. The object never changes its direction of motion. That was A, so this is the answer. The object is instantaneously at rest at some instant. Yeah, here it's at instantaneous rest when the velocity is 0. Okay, so the next question number 4. A person jumps vertically from rest of a diving board that is 5 meters above the surface of a deep pool. The person's speed reaches 0 meters, 2 meters below the surface of the pool. Find the magnitude of acceleration. We've done this question. I've sent the answer to this in the group, so you guys can see it from there. But if you guys still have any questions, you can ask me. Okay, so the next one. Okay, so guys, the meeting is gonna end right now. You guys should join again. It's saying less than a minute left. I'm just gonna see your answers, the questions you've asked me. Can we solve some can you tell us the group before you start any new chapter? Okay, sure, I will. Could you solve 15 questions? No, you didn't make a mistake. They are asking for magnitudes, and magnitudes are always positive quantities. Okay, so that's some mumbo jumbo. All right, thank you, man. Okay, guys, just join again because it's gonna end. I don't want it to